Okay, if you've never used OEE before, then you're probably missing some opportunities when it comes to your equipment. When it comes to any piece of machinery, once we take it out of the box and put it into use, it can be something on a factory floor, it can be heavy equipment used on a work site, it can be your lawnmower. Every piece of equipment has a lifespan, and the way we treat it will either lengthen that lifespan or short it. And OEE helps us to lengthen the lifespan, slow down the deterioration, and make that piece of equipment more robust. So what can we accomplish with OEE? It'll help us to determine the current state, baseline our equipment, identify the major losses, then prioritize what we need to do to drive improvement with them, then develop that improvement plan. So almost everything in life, for business or personal lives, we start with that baseline, where we're at today, where we want to be, and what do we need to do to get there. And OEE just helps us do that in regards to our equipment. Then that last bullet, monitor progress. We need to always know we're heading the right direction. So once we have our OEE, it'll help us to develop a compass or a blueprint to extend the life of that equipment and get the best reliability out of it. And it doesn't matter what type of equipment we're talking about, because all equipment has three characteristics, and that's availability, performance efficiency, and rate of quality. Under availability, we're looking at all the things that make that piece of equipment unavailable to us. So that would be maintenance, setups, changeovers, and we need to monitor and measure how often that piece of equipment is not available for use. Performance efficiency. Does your equipment start and stop a lot? Is it running at the design speed? If it was designed to run at a certain speed, do you find that with time you have to run it slower and it works more reliably? You know, we want it to run the way it was meant to run. And that rate of quality for the time that we're running a piece of equipment, is it doing what it is supposed to do? You know, if we're running a snow blower, we want it throwing snow. We don't want to spend time stopping and adjusting it, or same with factory equipment, you know, anything. When we're using it, we want it to work the way it's supposed to work. We want it to be reliable. Okay, for those three characteristics, availability, performance and efficiency, rate of quality, there are actually 6 major losses that OEE helps us to identify and measure. And those are setups and breakdowns, and those go under availability. For performance efficiency, we're going to look at idling and minor stoppages and that reduced speed that I mentioned. And then a rate of quality. You know, how long does it take us when we start a piece of equipment to get it dialed in? And then is it working the way it's supposed to, or are we producing defects and rework? I had a lawnmower that one side of it where the wheels are adjusted got stuck over time to where it wouldn't adjust. And we noticed as we mowed our lawn that we were kind of mowing a neat little pattern because it was cutting the grass cockeyed. The motor was working, but the lawnmower overall wasn't doing what it was supposed to do. Again, we want any piece of equipment we put into use to be reliable and robust and do what we want it to do. Okay, so let's look at those briefly. Okay, breakdowns. How often does your piece of equipment break down? How many hours through the course of a day, week, month is it broken down? And this can be normalized. So the U.S. Department of Labor did a study of manufacturing environments in the 90s and found that equipment only ran at about 50% of what it was supposed to be running in terms of time and what it was actually producing. And this can be normalized. That last bullet, you know, with time, we can get to where, you know what, we're just used to this piece of equipment being kind of cantankerous. You know, we got to fiddle with it, but, you know, we're used to it. Give it some tender love and a little time, and it'll be doing what we want it to do. Again, we normalize it. Setups and adjustments. How much time do we spend interacting with a piece of equipment? Adjusting it, swapping out parts, setting it up. All this takes away from its time of actual use. So we want to minimize this. There's a lean tool called a single minute exchange of die, or SMED, or quick changeover, where we look at how much time we spend with changeovers or starting up equipment setups, and we minimize it. We start by capturing that time. How often does the equipment stop? This picture is actually from a glass factory I worked in, where there were a lot of minor stoppages on the production lines that produced the glass tubes for fluorescent lamps. And they figured throughout the course of a year, at the rate it was stopping, it was costing about $65,000 a year. Okay, there's a lot of the power of OEE right there. Once we can quantify something, then it gives us a sense of urgency. It creates dynamic tension. This is where people can get behind driving the improvement because they want to reduce those negative numbers. From a safety perspective, it's when people are interacting with equipment that people tend to get hurt. The more robust and reliable equipment, the less people have to interact with it, and it drives and improves safety. Reduce speed. Again, equipment is designed to run at a certain speed, but it's also equipment is made out of lots of moving parts. Bearings, bushings, cams, cam followers, belts, V-belts. And what happens is with time, wear, maybe some contamination, improper lubrication, things of this nature, you start to get some vibration, some noise in the system. And we find that if we run the equipment slower, that vibration goes away and it becomes more robust and reliable. The way to fix this is to get the equipment back to its like new state, replacing those bearings, bushings, good lubrication, and that vibration goes away. So again, we need to capture this as part of that reliability. Defects and rework. And this might be one of the easiest for people to understand in that in a factory setting, in that when we're producing bad parts, we're producing bad parts. Again, if you have to do rework, you're scrapping out time, material, energy. On a job site with heavy equipment, you're using that equipment, and if it's not working properly, starting and stopping a lot, putting you behind schedule. Again, this is not what we want. We want reliability. We need robustness, and we need to design that into our maintenance programs and know that we're taking care of the equipment, that it's ready to use and reliable. Startup and loss yields. Startup and yield losses, the characteristics we'll look at. When we start up a piece of equipment, again, we want reliability that it's going to work the way it's supposed to work. In the terms of aviation, when it comes to aviation, we need to know that when that plane or jet takes off, it's going to stay in the sky. We don't get a second chance at some things. That's why that pre-flight checklist is so important. With heavy equipment, we might have a safety pre-inspection list prior to operation, like with a fork truck. And again, we need to make sure that everything is reliable and set to work the way that we need it to. With an assembly line with cars, we don't want recalls. We want everything working the way it's supposed to run. So we need to know these things up front. We need to anticipate problem, have control measures in place, and have a sense of confidence that everything is going to work the way it's supposed to work. Okay, there are 6 major losses, and for those major losses that we've gone over, there are targets for them. And the target is 0 for 4 of them. We want 0 breakdowns. We want no reduced speed, no vibration. We want the equipment running at its rated speed. No minor stoppages. We only want the equipment going down when we shut it down. And we don't want any defects or rework. Now, we know we might have some losses when we start equipment up, when we're dialing it in, and whenever we do a changeover. But we want to minimize that. We want it to be as minimal as possible. And that starts by capturing it. So we know what's going on, and then we can drive those improvements. Get that sense of urgency. Have numbers to back us up. Okay, there's a 6-step process we're going to follow to calculating our OEE. OEE becomes one of a very powerful key performance indicator or metrics to help us drive improvement, reliability, and extend the lifespan of that piece of equipment. So it's going to start out by, we'll collect our OEE. So we need good OEE data, and there's some tools we can use to do that. Analyze the OEE data. This is where we're taking it from raw data to information. We'll prioritize what needs to be improved. Take care of low-hanging fruit immediately. Then look at where we need resources, maybe design changes or whatever. But we have limited resources, and we want to make sure we're using them to the best of our ability. We want to find root causes and not just put band-aids on when we're dealing with these losses. So good root cause analysis is very important. Once we have that, we can implement our improvements and verify our countermeasures. We want to make sure that we've captured all the root causes to equipment losses, and the gains that we made are going to be consistent. We want to continually measure OEE information. So this needs to be a KPI that is regular to whatever business you're dealing with, where people get used to watching OEE data and use that as, again, a good key performance indicator. Okay, there's that. Okay, here's some tools that we'll use to analyze our OEE. So we got those 6 steps that I went over. Collect the data, analyze the data, prioritize the improvements, find the root cause, implement our countermeasures, and then verify. Constantly measure and monitor your OEE. Across the top, we got the tools we would use. An OEE observation form, worksheets, maybe Excel spreadsheets. I've seen Excel used extensively when it comes to OEE. What is a better approach would be to use software that's designed to capture OEE, where it can collect the information and collect the data and turn it into information you can immediately use. Analyze your major losses chart, Pareto analysis charts, or any tool to help you when it comes to that root cause analysis and looking at the data. So it could be Pareto charts, run charts, fishbone diagrams, but good analysis tools. And then put your improvement plan into place. Okay, once we've got that, then we've got a good roadmap, or we can create our blueprint towards driving improvement. Okay, let's look at a quick case study. Here is an example of an OEE observation form for a vertical turret lathe. To the left, we see that the lathe was supposed to run for 940 minutes, but the actual run time was 369 minutes. Here's our 6 major losses across the top. Now, I'll note first that there was times where it was scheduled down, so they had a couple lunch breaks or ran on 2 shifts. So we're only looking at the time that it was supposed to run. It was scheduled for that 940 minutes. But we have our 6 major losses across the top, and we see that we did have losses. We lost 225 minutes to idling and minor stoppages. We lost 140 minutes to breakdowns. We lost time to setup and adjustments, and then we were making scrap part of the time. Okay, here is an OEE worksheet. This would show you how to calculate your OEE, or it does show you how to calculate it. And I've used worksheets like this before with pieces of equipment. So people collect the data, we use this to write it all down, and by hand we can calculate it. Again, OEE is good information to have. Again, this gives us a number to quantify, to create that sense of urgency and dynamic tension, but we don't want to waste a lot of time with our calculations. You know, this is where, again, Excel or software does a much better job. Okay, let's look at that vertical turret lathe. It's important to remember that it was only scheduled for 940 minutes. The reason I point that out is through the course of a 24-hour period, if we look at it in terms of minutes, we could have ran it 1,440 minutes. That's what's available. Where that's important is knowing that it ran, or it was scheduled for 940 minutes, is that tells us our equipment utilization. We want to right size equipment for our needs. We don't want to invest a lot of money in equipment and have it sitting aside dormant, deteriorating, depreciating. So again, to an accountant or someone that's looking at equipment utilization, it's important to know. So for that vertical turret lathe, its equipment utilization was 65%. Now, does that count against us with OEE? No. OEE begins with scheduled time. We want to know what the equipment was scheduled for, and of that scheduled time, how much did we actually get to use? Again, the U.S. Department of Labor did a study in the 1990s and found that our equipment in the U.S., especially manufacturing, I think is what they focus on, the equipment only ran at about 50% of what it was slated to run for. So our equipment utilization, or equipment, so our equipment use was very poor, and that was using an OEE type calculation. So with that turret lathe, again, it was scheduled for 940 minutes. We actually got 369 minutes out of it, and all we're doing is adding, and then we're just dividing it out. So the calculation itself is extremely easy. We just need to make sure when we collect our numbers that we're collecting accurate numbers. So that vertical turret lathe, its OEE was 39%. So here we've got a breakdown of what those losses were. And typically idling and minor stoppages is one of the biggest losses when you do start calculating OEE. So again, lost capacity about 61%. Now once you find out where the main losses are, that's when you start using your root cause analysis tools, your Pareto charts, run charts, fishbone diagrams, and start looking where the big heavy hitters are, and you want to look at it from quantity, where the major losses are, and maybe cost. You know, if one has a higher financial impact, you might want to go after it first. But this is just giving your diagnostics, your information on where to start giving some attention to. World-class OEE is typically somewhere between 85 and 90%. And I caution businesses about going after those big numbers. What you mainly want to do is use your OEE, get your diagnostics, and start driving improvement. Look for percentage improvements. As long as you know you're heading the right direction, don't worry about capturing world class at this point. That could be really expensive and costly to go after. But if you're driving improvements, you know you're heading the right direction. Again, everything is either moving forward or backwards. You just need to know where you're at with your equipment, and you're doing everything you can to make it reliable and slow down that deterioration. With that, I'll turn it over to Barry.